Hey guys, I'm Tony, owner and operator of St. Tony's Heating and Cooling here in Meridian, Idaho. And this was an interesting one where I got a call from a friend with a property that he recently purchased. They're in the remodeling process and the furnace stopped working. So I go out there and what I found was a dirty blower wheel causing the furnace to run too hot, and it would shut off, it would run, shut off, and eventually it'd lock itself out completely. So we also found there was no filter installed. The other interesting thing I found was the capacitor that was installed was too small for the universal blower motor that the previous owner had replaced, but they didn't upsize the capacitor to make that universal blower motor a 1/2 horsepower blower motor. So I corrected that, got the airflow moving better until I could come back and pull and clean the blower wheel. So in this video, we go through the process of how we diagnosed the system, what we did to correct it, and the outcome of the process. So stay tuned to the end of the video. And until next time, blessings. Back at that furnace that had the dirty blower wheel, we're gonna pull the whole housing out, remove the motor, clean the blower wheel, check the evaporator coil, and we're gonna clean that if it needs cleaned as well. We're gonna check the secondary heat exchanger and make sure that isn't clogged up as well. So stay tuned guys for the rest of the video. On the nameplate of this furnace, we can see that the max outlet air temperature should be 180 degrees at the most. The air temperature rise should be 40 to 70. Here you can see it's 190.6 degrees coming out of the supply and 115 degrees temp rise. The total external static pressure was 0.41 without a filter installed because they did not have a filter installed. Typically I see it higher than that, but that was the reading we had before cleaning. This furnace uses a universal PSC blower motor, not a variable speed ECM. When the blower motor was replaced, a universal PSC motor was installed. With these motors, airflow depends heavily on using the correct capacitor. What I found was that the capacitor installed didn't match the motor's requirements for a 1/2 horsepower blower motor because that's what this unit had before according to the unit rating plate. Once I corrected the capacitor and installed a 15 microfarad capacitor, leaving the blower on high speed, the furnace was able to run without tripping the high limit nearly as often. That allowed the system to operate and keep the space warm until we could come back, pull and clean the blower wheel, and clean the secondary heat exchanger. I thought this would be a good one. So they put the medium high for the cooling, the high speed for the heating. Whoever installed looks like a universal blower motor on this, and they didn't upsize this to a 10 microfarad capacitor to make that universal motor a 1/2 horsepower. The nameplate on this Lennox furnace is a 1/2 horsepower. The max outlet temperature on this gas furnace is 180 degrees. It was coming out 190 degrees. You can see here, max outlet temperature, 180 degrees, and the temp rise on this is 40 to 70. It was 115 degree temp rise. All right, Turbo 200 Mini, we set it for the 10 microfarads one. Capacitor, we got 10 now, instead of 7.5 on the other one. Now this will help it run at a 1/2 horse on this universal motor. And we flipped our 2 wires, so let's check our temp rise now. After I flipped those 2 wires and put the correct capacitor, I actually found that it was still running too hot, so I put the high speed back for heating until I could come back, pull and clean the blower wheel, and clean the secondary heat exchanger. This right here is something most homeowners never see, and honestly a lot of technicians skip. We measure static pressure to verify how hard the blower is working against the duct system. High static pressure means restricted airflow. It's basically the balloon force of the air exerted in there on the ducts. It's almost like high blood pressure. Restricted airflow leads to overheating, limit trips, and premature failure. I don't just clean a system and leave. I measure it because numbers don't lie. They say if you're not testing, you're guessing. And if we're going to say it's fixed, we verify it's fixed. capacitor, turn the gas off, let it cool down. That way I don't have to go, if I take this door off, it just lets the heat exchanger and the high limit, everything in there cool down for a second with the air moving still before I pull the door off. That way I don't got to go downstairs, turn it off all the way downstairs. Blower motor's not super hot or anything. Before I can even get the blower wheel out, there's a process. The control board has to come out of the way, the capacitor has to be safely discharged and disconnected, every motor speed tap and control wire has to be labeled and removed carefully. So I take pictures of the wiring before so that this is a smooth process at the end. This isn't something you just yank out. If you damage a board, bend a bracket, or miswire a speed tap, you create bigger problems. So this part right here, this is the methodical teardown. Taking it apart properly so it goes back together properly. A clean removal means a clean reinstall. Alright, this is the point where we remove the entire blower housing assembly. The motor and wheel come out together as one unit. From here I'll take it outside so we can separate the motor from the blower wheel and clean everything thoroughly. This step matters because you can't properly clean a blower wheel while it's still inside the cabinet. It has to come out so we can access every blade and protect the blower motor. Next I'll show the process of removing the motor, cleaning the wheel, and then we'll put everything back together the right way. Yep. Sure enough, guys, there she is. There's the secondary heat exchanger. It's like a coil, basically. And that coil is basically plugged. We're gonna clean it, boys. Got the blower wheel out. There's the dirty blower wheel. Here's the dirty secondary heat exchanger. I knew it'd probably need cleaned. So we're gonna clean that and the blower wheel. So quick context here, this house actually had no water turned on. The owners before like tied the water lines of the home back into like the water at the street or something. So the water was completely shut off at this point. I couldn't hook up a hose. Most of the neighbors weren't home, but one kind neighbor filled up my Home Depot bucket twice with hot water, and I had just enough water to clean it properly. So we had to work with what we had. I mixed coil cleaner in a bucket and soaked the blower housing and wheel, shaking it out and rinsing it carefully. Not ideal conditions, but the goal is still the same: get it properly cleaned and restore airflow the right way. Wow, she's shiny, guys. Wow. Spray and stuff. Might as well soak that blower wheel. Almost out of water. Oh, mercy. Did the best I can. Why not? 10 times better. Guys, I felt a raindrop, I think. If it starts raining, I'm going to let this thing get, the Lord's going to wash it. Thank you, Lord. I don't know if it might work out perfectly. Guys, I just discovered something new in my HVAC career. This brush is exactly what I wish I had. Dude, look. Detail brush. Man, this thing, I should have did this earlier. Just picked this up actually. So. Gosh, so much quicker. Look, I can literally do four of them almost at once. 3 of them. All right, here's the clean. Wheel got as clean as I could with the amount of water that I have, and I scrubbed everything down. No water here, so I had to fill up a bucket from the neighbors. But I got everything off of it that was built up. This thing turned out shiny. I am very happy with how shiny this housing turned out. Some of this is still kind of stained. I scrubbed it and sprayed it and scrubbed it, metal brushes, and got it as clean as I could. So let's go get it put back in. Okay, much better. So we got a new bracket on here because they had the bracket done wrong. We got the wheel lined up properly. This is no longer hitting. So much better. Belly band centered around it instead of these brackets they used on it. I mean, it worked, but so much better, cleaner, properly installed, proper capacitor for the right torque, for the right horsepower. DIY DW. A do-it-yourself done wrong. Anyway, so we got a new belly band on here. We centered it, okay? And we also centered this blower wheel. So before, you saw that this was not centered. Okay, it's centered now. In fact, when I turned it sideways, it was so loose, this was touching when I took this housing out and I shifted it like that. I can't believe it wasn't hitting in there. But much better, cleaner, proper. We went ahead and cleaned all this return out because it was just filthy, and we cleaned out the return over here as well. It was just filthy. So we went ahead and cleaned it all while we were in here. And we cleaned that secondary heat exchanger the best we could with no running water, just some good coil cleaner. All right, checking the evaporator coil. I've got my probes in, I got my psychrometer, my return air psychrometer, my supply air, basically temperature probes, and they also read humidity and things like that. And so I'm using the Measure Quick app to look at live data. We're checking the temperature rise and making sure this furnace is operating within manufacturer specifications. Earlier, before cleaning, this furnace was tripping on high limit. I had a temp rise of like 115 degrees. I've got this temp rise now down to about 63, 64 degrees. The max that it can be is 70. So I have it in a much better acceptable range with a few degrees reserved for the filter to get dirty and it to get close to the max, but not all the way there, tripping the high limit. So now that the blower wheel and secondary heat exchanger are clean, I'm confirming the airflow is back where it should be. You can see here on the app, we're now within acceptable temperature rise range. That tells me airflow has improved and the furnace isn't cooking itself anymore. This step matters. Cleaning without verifying performance is incomplete service. Anyone can wash parts. What protects equipment long term is confirming it's running safely and within spec. If you made it this far, I appreciate you watching. This job is a perfect example of why thorough diagnostics matter. A dirty blower wheel, wrong capacitor, improper setup, all of that led to overheating and shutdowns. Once we cleaned it properly, corrected the capacitor, and verified airflow and temperature rise, the furnace operated within spec and stopped tripping. HVAC isn't just about swapping parts. It's about understanding airflow, combustion, and system performance, and making sure it's done right the first time. If you value thorough work, proper testing, and clear explanations, that's what we focus on. Thanks for watching. This is St. Tony's Heating and Cooling, where we enjoy restoring comfort and peace of mind one job at a time.